Hello everyone, this is Mr. Kingsbury. I'm here today from Algebra 2. We're talking about our radicals unit. Today we're going to talk about inverses, specifically finding them using tables and graphs. So our essential questions are, there's two of them, what is an inverse? And number two, how do I find the inverse of a table or a graph? So what is an inverse, or the inverse of a function? Let's define it first. And here's how I'm going to find it. And it's real simple. I'm going to define it in simple terms. Two functions are inverses if they undo each other. A real simple example would be like this. Well, I don't want that to be an official example. A really official example, simple example. If you had f of x equals x plus 2 and f inverse with the little negative 1 there of x equals x minus 2. They undo each other, right? When we talk about function composition, we can get into some other ways that you can prove it. But essentially, think of it like this. If these are both machines, and I put something into this machine, I put a number into the machine, I get a 2. Or I add 2 to it, right? So then I get out some specific number. If I take that number that I get out of the machine and plug it in here, I subtract 2, I'm back to where I'm started, right? So if I put let's say I put a 3 in here. 3 plus 2 is 5. 5 minus 2 is 3. This undoes what this did. That's how I know that they're inverses. That's not going to be terribly important for us, but you need a basis to work off of. We're going to look at today how we find the tables of inverses and the graphs of inverses, kind of with the graphs thing. I'll explain more when we get there. So with tables, what do we do? Well, it's actually pretty straightforward. So with tables, flip the x and the y. That's all. Let me give you an example. Here's example 1. All right, let's say that you are given this table. This is, we'll call this f of x. I'm trying to use the notation, right? The function notation. Here's my x, here's my y. So let's say that this has the following points on it. Let's say -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. That's the function. To find the inverse, which we would write f inverse of x, the little -1 tells us the inverse, or that it's an inverse. To find that, we would simply flip-flop everything. So -2, 4 is my point in the function. So in the inverse, it would simply be 4, -2. My point here is -1, 1, so I flip-flop them. In the inverse, it would be 1, -1. Now, these next 2 points can be a little confusing. I've got 0, 0, but when I flip-flop them, I still get 0, 0. Same with 1, 1. When I flip-flop them, I still get 1, 1. I still flip-flopped them. They just end up being the same point. And then we've got 2, 4. I flip-flop that, and I get 4, 2. It's that simple. It's all there is to it. So I'm not feeling like I need to spend tons of extra time on this. You just flip them. So you'll find problems on the homework and on the test where we give you a table and we want to know what does the table of the inverse look like, and you just flip the x's and the y's. Or we may say which of the following points could be on the table of the inverse of the function that has this table. And we give you a table, and you just need to figure out which of the options we give you is one of those points. Flip-flop. It's pretty straightforward. It's actually more confusing to talk about it than to actually do it. So my apologies for that. How do we do it with graphs? Well, first of all, with graphs, you reflect it over the y equals x line. We're not going to actually have you do that. Instead, what we're going to do is we're going to make a table, flip the X and Y, and then graph it. And we're going to even do one better, and we're not going to make you graph the new table. Not at all. All right. So let me just give you a quick example. It won't take long, I promise. So what is this? Example 2. All right. So first you need a graph. So we'll graph this. All right, let me just put a graph on here. And honestly, I'm just kind of thinking this up as I go. I'm thinking I like the idea of an absolute value one. I like that. So let's put the bottom like that. And I realize this graph is not fabulous, but it'll work. What's most important is that I have some values on here. All right. So here's what we're going to do. We're going to make our XY chart, and I'm going to put these ordered pairs on there. So I've got, what is that? 0, 0, and then 1, negative 2. Then we've got 2, 0, 3, 2, and 4, 4. Nice. Then the next step, so this is f of x. This will be f inverse of x. We flip them. 0, 0, when you flip it, it's still 0, 0. 1, negative 2 becomes negative 2, 1. 0, 2, 2, 0 becomes 0, 2. 3, 2 becomes 2, 3. And 4, 4 becomes, well, 4, 4. And I want to point out, and I don't know if this is obvious or not, but negatives don't change. Okay, like right here, this is 1 and negative 2. It became negative 2, 1. I didn't drop a negative. I didn't add a negative. It didn't switch. It's the same. Some people feel like anything that is negative needs to become positive. Anything that's positive becomes negative. That's wrong. You don't do that. The numbers stay the same. You just flip their locations. That's it. And that's all we want you to do there. And in fact, the questions that you'll get will be like this. We'll say that f of x is graphed below. There's a point marked on it. What would that point be on the graph of f inverse of x? And so you literally just take the ordered pair that's graphed on the graph and you flip the x and the y. As far as inverses go, that's all you're really going to need to do for now. When we will talk at a later date about coming up with equations, but that's a completely different thing where you're doing it algebraically. It doesn't involve graphs or tables. So there you go. That's all I've got. Hopefully that was helpful. And have a great day. Bye.